All right, Intro to Cal and Statistics, let's go. Section 7.4, Matrices. So this section is really short. We're going to learn how to define matrices and how to work with them and their dimensions. So that's our objective. Write matrices and identify their dimensions. So here's the definition of a matrix. It's a little blurry and you don't have to worry about writing it down. If m and n are positive integers, then m by n matrix is a rectangular array like below. So what's important to take from this is your rows are in the top going, your columns are in the top going down and your rows are on the sides and they go across. So just like a normal table, rows are sideways, columns are up and down. It's really important to know where those are located because this is how we're going to be defining our matrices. So m by n matrix, where m is the rows and n is the columns. So you can think of it as rows by columns. So I don't know if you want to come up with a little saying, R then C, like running to college. I don't know, running, college. I'm sure you'll think of something creative. But this is how we're going to define our matrices. So it's really important that it's row by columns. So here are a few problems where we can define the dimensions of our matrix. So if you want to pause this and write these down, go right ahead. If you look at the first one, you have a matrix that's defined just by the number 2. So this matrix is actually a 1 by 1 matrix. You have 1 row, 1 column. Our next matrix has 1 row, but 4 columns. So this is a 1 by 4. Remember, it's row by column. So how about the next one? We've got 2 rows, 2 columns. So this is a 2 by 2 matrix, which we'll actually see later that that's a square matrix. A is also a square matrix. For D, you've got 3 rows, 2 columns, so it's a 3 by 2. And then the last one is E. You've got 3 rows, but only 1 column. So this is a 3 by 1. So that's how you would determine the dimension of a matrix. That finishes 7.4. So we're going to go right into 7.5, operations with matrices. So here we're going to determine whether 2 matrices are equal. We're going to add and subtract and multiply by scalars. Then we're going to multiply matrices together. And then, of course, some real-world problems. So let's go. What are we waiting for? Example 1. So equality of matrices. So when defining a matrix, this is row 1 and row 2. And we know that we define their dimensions row by column. So you can write your matrices values by locations. This is location A sub 1, 1. It's row 1, column 1. So it makes sense that the value, in our bottom corner, A sub 2, 2, is row 2, column 2. So right here, we're just trying to figure out what our values are. So A1, 2, 2, A1, 1 is going to be the value 2. Here you have A1, 2. Here you have A2, 1. And then, of course, A2, 2 is 0. For matrices to be equivalent or equal to, they have to have the same dimensions. This is really important. And their corresponding values or entries must also be equal. So look at these first two matrices, for example. 2 and 2, same location, -1, -1. Next, you've got the square root of 4, which is 2, so this works. And 1/2 can also be represented by 0.5. So this is definitely two matrices that are equal. But if you look at the next two examples, here you have a 3 by 2 and a 2 by 2. Those dimensions aren't equal, so therefore those matrices aren't equal. Even though the last row is 0, 0, they're still not equal because these are placeholders. They're actual values. You can't dismiss zeros in matrices. So let's go ahead and add them up. You can only add matrices together if they have the same dimensions. So this is why it's really important to know the dimensions. And then you add locations together. So I'm going to start by adding my 2 by 2 with my 2 by 2. Here I've got -1 plus 1 is 0. So that's my first location. And then I have 2 plus 3 is 5. So that takes care of my first row. Now my next row, I have 0 plus -1 is -1, and then 1 plus 2 is 3. So far, so good. My next matrix, I've got a 3 by 1 plus a 3 by 1. So dimensions are equal, so that means I can add them together, and again, just add across. So 1 plus -1 is 0. -3 plus 3 is 0. -2 plus 2 is 0. So I get a 0 matrix, which is fine. That's the answer. And then for C, I start off with a 2 by 3, and I want to add that to a 2 by 2. My dimensions aren't the same, so this is actually undefined. So remember, when adding or subtracting, for that matter, matrices, the dimensions have to be the same. Almost done. Last example. So here we've got scalar multiplication. We're taking matrix A, our 3 by 3, and multiplying it by a factor of 3. So 3A is also going to be a 3 by 3 matrix, but I'm going to multiply each value or entry by 3. So 3 times 2 is 6. 3 times 2 is 6. 3 times 4 is 12. So that takes care of my first row. 3 times -3, -9. 3 times 0, 3. 3 times -1, -3. Keep going with that last row. 2 times 3 is 6. 3 times 1 is 3. And 3 times 2 is 6. So if this is matrix A, this is matrix 3A. It's 3 times my defined A matrix. So that's scalar multiplication. All right, so for homework, I want you to try these 3 problems. Here's your first one. For 1 and 2, I want you to give me the dimensions. Is it a 5 by 4? Is it a 3 by 2? Is it an 8 by 10? So tell me the dimensions of number 1 and 2. And then for number 3, I want you to do 2 things. I want you to add matrix A and B together. So that's part A. My board is acting kind of funny. Hold on. So that's part A. And then for part B, I want you to tell me what 3 times matrix A is. And then also, why don't you give me 2 times matrix B? All right, that takes care of this. Hope you